Okay, so today we are starting with uh, cryptography definitions. Now, first of all, we need to learn about algorithm. I mean, most of the time, everybody is going to use the term algorithm. So, algorithm are what? They are the set of mathematical rules used in encryption and decryption. I mean, whensoever you are going to use, or I'm going to use any type of word like algorithm, it means that this is actually a mathematical rules or set of mathematical rules that can be used in to encrypt and decrypt your data, right? That is what the algorithm is. I mean, अगर मैं बात करता हूँ symmetric algorithm की, asymmetric algorithm की, right? All these things would be coming under the category of certain sort of mathematical rules and regulations which are being used in order to encrypt or decrypt your data. That's what you can call it as an algorithm. Then we have a cipher. Cipher, already I have told you that another name for an algorithm. I mean, cipher is sort of algorithm that is being implemented over a text, and your text is being converted into a cipher text or encrypted text, right? You may call it as an encrypted algorithm. You may call it like that. Then you have the cryptography, science of secret writing that enables you to store and transmit data in a form that is available only to the intended individual. Now, see, what is a cryptography definition is kindly close the mic, guys. Mic बंद करें अपना. Science of secret writing that enables you to store and transmit data in a form that is available only to the intended individual. अब cryptography हमने पढ़ी तो बहुत है, I mean definitions भी पढ़ी हैं, but actual definition is when you are going, it is a science of secret writing in which that enables to store and transmit our data. I mean the encrypted data is being transmitted over some medium that is being available only to the intended individual. I mean the person who is legitimate to see that information is only for that particular person or that particular individual. I mean, let's suppose the data is being sent from a source to a destination, so that cryptographic or encrypted information would only be available for the source as well as for the destination. In between, that data must not be intruded, right? Then we have the crypto system. What might be a crypto system is hardware or a software implementation of cryptography that transforms a message to a ciphertext and back to a plain text. As I have given you the example of pretty good privacy PGP tool, so it is a sort of a hardware or software implementation or a program that might be transform your message from a plain text to a encrypted text and for an encrypted text again back to a plain text. The whole function is being performed by a crypto system. That example of that particular crypto system might be a PGP, that is called as your pretty good privacy, right? Then we have another definition that is called as your cryptanalysis, that is practice of breaking cryptic system. I mean how you are going to break a particular cipher or an encrypted text, right? And then you have to analyze how the algorithm is being broken, how the keys are being used. I mean all these things, the analysis or the study of all these things is called as your cryptanalysis, right? I mean हमने किस तरह से एक algorithm को break करना है. I mean what are the techniques that might be used. The analysis of all these things is being called as your crypt analysis, right? Then we have a cryptology, the study of both cryptography and cryptanalysis. अब देखिए अगर हम cryptology, cryptography और cryptanalysis को combine कर लें तो उस पूरी की पूरी study को हम क्या कहेंगे कि this is what you can call it as a cryptology, right? The study of both cryptography and cryptanalysis is being called as your cryptology. Then you have the data origin authentication, proving the source of a message. I mean system based authentication. Let's take an example of a data. I mean whether the data is authentic or not. I mean from which source your data is being coming. This type of authentication is being called as your data origin authentication. I mean proving the source of a message from where the source I mean message is coming. That's what is called as your data origin authentication. Then we have the encipher, act of transforming data into an unreadable format. That is what you can call it as an encipherment. I mean आप अपने data को crypted I mean उसको encrypt करके एक unreadable format के अंदर change करते हैं, that particular procedure is being called as your encipherment, right? Then we have an entity authentication, proving the identity of an entity that sends a message. I mean, you need to confirm that from whom that message is being coming. That's what how you are going to ensure the person who is sending that particular message. That is what you can call it as an entity authentication. Then you have another definition that is called as decipher or decipherment, act of transforming data into a readable format. I mean something that is going to be converted into a plain text from a encrypted text. That procedure is being called as your decipherment, right? And then finally you might have a key. The definition of a key: the secret sequence of bits and instructions that governs the act of encryption and decryption. Now most of the time you people have heard about the definition. I mean we are commonly using the word key or key length or key space or like that, but actually what the key is. So you have to understand this concept in this way that this is a long bit of streams, I mean the combination of zeros and one, which is being used to encrypt and decrypt your data, right? This is what you can call it as a key. So these were the basic definition. Okay, still there are remaining. Okay, then we have the key space, a range of possible values used to construct keys. As I have told you in the previous class, in the last discussion, that key space is something, the space from which your particular key is being selected. ठीक है जी, हमारे पास एक space है, there are number of zeros and ones values or the binary values, and from those particular I mean to say that range, we have to select any one, two or three of the value. That is what you can call it as key, and the space is being called as your key space, right? Then you have the plain text data in the readable format, also referred to as a clear text. I mean the data on which the encryption is being applied. I mean before applying encryption, the data in a normal format is being called as your plain text, or in the readable format you may call it as a plain text, right? In the same way, we might have the receipt, acknowledgement that a message has been received. I mean, I have told you that like connection oriented protocol like TCP, right? As we have gone through in the computer networks, that when you are getting some sort of receipt from the receiver, that particular message has been received at the receiver's end, that particular acknowledgement is being called as your receipt, right? And then you have the work factor, estimated time, effort, and resources necessary to break a crypto system. That's what you can call it as a work factor. And I also have told you the definition of work factor in our previous class. Actually, the time, effort, and the resources which might required to break any type of crypto system. This is what you can call it as a work factor. Fine. So, classification of the field of cryptology. I mean, how we are going to divide this particular technique. I mean, how we are going to bifurcate this particular field. I mean, at the top, we have the cryptology, right? As we have gone through, the cryptology is the study of your cryptography and cryptanalysis. We are going to divide this particular field into two subfields. One is called as your cryptography, another one is called as your cryptanalysis, right? Right now we have to emphasize on our cryptography. Cryptography is being divided into again subparts: the symmetric ciphers, asymmetric ciphers, and then protocols. And then your symmetric ciphers are being divided into block ciphers, and then you have the stream ciphers. Now these are not the simple things. We have to go through each and everything in detail. Cryptanalysis, as I have already told you, this is a way or technique in order to find what are the techniques are being used to decipher certain sort of algorithm or break certain sort of algorithm. The study of that particular thing is being called as your cryptanalysis. ठीक है जी. For the time being, we should not be exploring our cryptanalysis side. We are only emphasizing on our cryptography part in this particular subject, and we have to go through our symmetric algorithms, asymmetric algorithms, and different type of protocols, and then we need to divide our symmetric one into block ciphers and stream ciphers. We have to gone through we have to read each and every one in detail with the help of examples, right? Then Encryption में हमारे पास the one and the first and foremost idea that came into being is called as your one-time pad. Now actually one-time pad is a perfect encryption scheme because it is considered unbreakable if implemented properly. It was invented by Gilbert Vernon in 1917, so sometimes it is referred to as the Vernon cipher, right? So this cipher does not use shift alphabets as do the Caesar and Wigner ciphers discussed earlier, but instead uses a pad made up of random values. Now see, a one-time pad is a perfect encryption scheme. Now encryption, you people are well aware okay, what I mean by the encryption. Encryption is something your plain text is being converted into a cipher text. That is the main functionality of a one-time pad, right? If it is an encryption scheme, this means that we are actually going to convert our plain text into a encrypted text or a cipher text by using a one-time pad, right? And it is considered unbreakable. I mean, it is very much strong if it is being used properly, right? Or if it is being implemented properly. That was been invented by Gilbert Vernon in 1917. So can you imagine how old it is? I mean, in 1917 it was being invented, and even nowadays it is being used very generally, right? In cryptography. So sometimes it is referred to as the Vernon cipher too, right? So this cipher does not use shift alphabets as do the Caesar or Wagner cipher. I mean, I think we people are well aware about the Caesar cipher, in which we are going to just shift the values three words forward or three words back or like that, right? But actually it doesn't use these shift alphabets, but instead use a pad made up of random values. But this, I mean, one type pad is using certain sort of bits or the stream of bits as a pad, and that particular pad is being used to encrypt that particular data. Now, how it is going to be used, I would be telling you. So our plain text message that needs to be encrypted has been converted into bits, and our one-time pad is made up of random bits. Now see, in this particular scenario, your plain text, you have to convert it into a stream of bits, I mean in the form of zeros and one, and your one-time pad has to be converted into a zeros and ones, I mean into stream of bits. Now this encryption process uses a binary mathematical function that is called as your exclusive OR, right? That is usually being abbreviated as XOR, or you may call it as XOR, right? I think you people are very much well known about this particular operation, or the binary logical operation, whatsoever it could be. Now your message streams, your key streams are being XORed, and in result what you are getting, that would be called as your cipher stream or your in cipher text. Is that clear, guys? ठीक है जी. तो अब इसमें if you can look onto this particular diagram, what you might have, let's suppose you have a text that is called as hello mom, I have dropped out of the school and decided to travel, please send money. This is a text, or this is a message that you want to encrypt by using a one-time pad. Now on the second, in this particular picture, this diagram, this is your one-time pad. This is again the number of binary values which you have set so far. Now this one-time pad would be XORed with this particular textual value, right? जो आपके पास text आपने bit streams में change किया है, दोनों को आप XOR करेंगे, and the resulting text would be your cipher text, right? Now I mean, you people are very much well aware about this particular operation. XOR कैसे होता है? 101, 011, 00 and 11 becomes 0, right? The same values would be representing at something like different, right? So the first bit of the message is XORed to the first bit of the one-time pad, which result in the cipher text value 1. The second bit of the message is XORed with the second bit of the pad, which result in the value 0. Then what we have, we need to change back our cipher text to our normal text or plain text. हम फिर क्या करेंगे? What we have the cipher text, and then we have the one-time pad again. Then we have to XOR again your cipher text with your one-time pad, and resulting value would be your plain text. अब इसमें स्पेशलिटी क्या है? स्पेशलिटी ये है कि आपका जो वन टाइम पैड है ना, that needs to be present at the sender's end as well as at the receiver's end. ठीक है. अब इसमें ऐसा नहीं होगा कि आपका लेट्स सपोज यू आर गोइंग टू सेंड योर प्लेन टेक्स्ट, आई मीन at the sender end you have encrypted your data with one time pad, right? That particular data would be sent to the receiver by any means, by an internet, by an email, or whatsoever it could be. But make sure your one time pad that is seems to be a key, I mean to say that agar hum assume kar le कि this is a sort of key that needs not to be travel with along with that particular text. ठीक है जी, ये आपके पास टेक्स्ट के साथ ट्रेवल नहीं करेगी. इट नीड्स टू बी आई मीन टू से दैट डिप्लॉयड एट द रिसीवर्स एंड बाय सम अदर मीन्स. आई मीन लेट टेक एन एग्जांपल ऑफ एनी अदर एग्जांपल, राइट? कि जी अगर हम कोई टेक्स्ट भेजते हैं या हम कोई इस तरह की सेंड करते हैं ईमेल, लेट सपोज वी आर गोइंग टू सेंड इट थ्रू एन ईमेल, लेकिन हमने जो उसका अदर थिंग्स हैं दे आर गोइंग टू बी सेंड थ्रू अ रजिस्टर्ड मेल, जो हमारे पास पार्सल होता है जिसको हम कहते हैं, जो हमारे पास सरफेस मेल होती है उसके थ्रू हम सेंड कर दें. द सेम अप्लाइज ओवर हियर. लेट टेक एन एग्जांपल कि जी वी आर सेंडिंग द टेक्स्ट थ्रू एन ईमेल, right? Or we are going to send the plain text through an encrypted text through an email, and the key that is called as your one-time pad needs to be transferred by some other means, some parcel or some like PCS or something like that. I'm just going to give you an example. There are some other ways to do that. So now that particular, actually we are going to ensure the secrecy of that particular one-time pad. If somebody is going to know that particular one-time pad, then it can easily decrypt the information that is being traveling over a network. ठीक है, अगर आपने one-time pad से किसी text को encrypt किया है, तो अगर on the way आपका one-time pad किसी intruder को मिल जाता है, तो it can easily decrypt that information. So one-time pad must be present at the sender's end as well as at the receiver's end. तो अब जैसे receiver end के पास one-time pad मिलेगा, वो आपके पास आपके encrypted text के साथ उसको ज़ोर करेगा, and then it would be getting the reversed plain text. This is how your one-time pad works. For a one-time pad encryption scheme to be considered unbreakable, each pad in the scheme must be made up of truly random values. एक तो आपके पास जो आपका pad है, it must be consist of a truly random values used only one time. आपके पास pad जो है वो it has to be used only for once. It must not be repeated for different set of, I mean to say that scenarios, right? Third point is securely distributed to its destination. जो अभी मैं आपको बता चुका हूँ कि आपका जो one time pad है, it must have to be distributed from source to a destination in a very secure way. If on the way that one time pad is being leaked or it is being compromised, then your whole encrypted text would be compromised. Then you have secured at senders and receiver side at least as long as a message. अच्छा, अब ये जो last point है ना, this is very important. इसका मतलब ये है कि आपका जो जितना लेंथी टेक्स्ट होगा, लेट्स सपोज अगर 50 बिट्स या 512 बिट्स का आपके पास टेक्स्ट है, उतना ही लेंथी आपका वन टाइम पैड होना चाहिए. आई मीन मैं बाइनरी की बात कर रहा हूं, ठीक है? इट मस्ट नॉट बी स्मॉलर देन योर टेक्स्ट. अब उसका रीजन है, लेट्स सपोज आपके पास 100 बिट की एक टेक्स्ट वैल्यू है और आपके पास 20 बिट्स का वन टाइम पैड है, then how can you, I mean to say that apply encryption by using 20-bit one-time pad? It means that you are going to use this one-time pad 5 times. I mean आपने 20 bits को पहले encrypt किया, फिर आपने दूसरी के साथ उन्हीं 20 बिट्स के साथ अगेन आपने encrypt किया. This means that you have applied same 20 bits for the 5 times in order to encrypt your plain text, that is then 100 bits plain text. ठीक है, तो अगर आपके पास 100 बिट का plain text होता तो हर एक बिट आपके पास I mean करस्पॉन्ड करती हर एक टेक्सचुअल डेटा के साथ, ठीक है? लेकिन यहाँ पे सिचुएशन क्या बन रही है कि आपके पास जो प्लेन टेक्स्ट है वो 100 बिट्स का है और जो आपका वन टाइम पैड है दैट इज ऑफ 20 बिट्स. अब होगा क्या कि हमारे पास द I mean to say that जो one time pad है that is smaller than your plain text bits, right? So what we need to do, we need to repeat this particular procedure for a 5 time in order to encrypt our 100 bits to a cipher text. ठीक है, अब हमने क्या किया, 20 बिट्स को 5 टाइम जोर किया अपने प्लेन टेक्स्ट के साथ, तो क्या हुआ, we would be getting 100 bits encrypted in a cipher text, right? But this is not a right way, right? This is possible, but this is not a right way. Why? Because आपके पास patterns generate हो जाएगी. I mean, there are certain patterns are going to be generated, and your invader is going to know that this series of bits are being used, repeatedly in this particular text. Let's take an example. I mean, आप पहली 20 bits के साथ जो XOR operation perform करेंगे, वही XOR operation आप second 20 bits के साथ करेंगे. Again, the same 20 bits would be used for the third time, and the same 20 bits would be used for the fourth and the fifth time. तो आपके पास एक सिमिलर पैटर्न जनरेट हो जाएगा, ठीक है? एंड दैट सिमिलर पैटर्न is very much, I mean to say that, dangerous and for the normal people, and definitely invader is going to get a very secret information from this pattern and can compromise your encrypted text by looking onto that particular pattern. So this is why you must not have to use a one-time pad that is smaller than your plain text. Your plain text values, bit values, and your one-time pad values must both be equal, or you may call it as the same. So that is all regarding your, I mean to say that, one-time pad. So a number of generator is used to create a stream of random values and must be seeded by an initial value. This piece of software obtains its seeding value from some components within the computer system, like time, CPU cycles, and so on. So although a computer system is complex, it is a predictable environment. So if the seeding value is predictable in any way, the resulting value created are not truly random, but pseudo-random. अब देखें, इसमें ना, इस टेक्स्ट के अंदर एक बड़ी जनरल सी बात बताई है उसने कि let's suppose if you want to generate any type of random value, I mean it is talking about a key. That random value might be generated by taking certain sort of values from your computer. I mean your time, computer's time, your CPU cycle, and certain other attributes. They are being combined to generate any type of random value that can be used as a key for any type of situation. I mean, this is just an example, right? But you know that this is also predictable. I mean, किसी भी कंप्यूटर का टाइम, CPU cycle या जो other attribute आप use कर रहे हैं, if that is being known to any type of attacker, and this is very much obvious, it is very general information and can be known to any type of attacker, तो उस basis के ऊपर वो कोई भी किसी भी की को compromise कर सकते हैं, ठीक है? So what we need to do, we need to add certain sort of values, or we need to randomize these sort of values. तो हम इनको क्या कहते हैं कि these are not actually random value, but these are the pseudo random values, ठीक है? इसके अंदर आप different sort of IR value जो हम कहते हैं, I do not exactly remember that particular term, that is being added into that particular pseudo random value, so that your key must be different from all other scenarios. I mean, it must not be known to normal people, ठीक है जी? So we must not have to use the time, CPU cycle, and other attributes which are being used inside a computer, because these are the predictable values. तो हमने इनको use नहीं करना, लेकिन हमने डिफरेंट जो आपके पास वैल्यूज हैं उनको यूज करते हुए एक सूडो रैंडम वैल्यू जनरेट करनी है, दैट मस्ट नॉट बी प्रेडिक्टेबल, राइट? सो नाउ वी हैव अनदर टाइप दैट इज कॉल्ड एज योर स्टेगनोग्राफी. और स्टेगनोग्राफी क्या होती है? Steganography is a method of hiding data in another media type, so the very existence of the data is concealed as illustrated in the figure. Only the sender and receivers are supposed to be able to see the message, because it is secretly hidden in a graphic, wave file, document, or other type of medium. The message is not encrypted, just hidden. Now see, steganography is a type of hiding data, ठीक है जी? अब ये आपके पास एक encryption का mechanism है, जिसमें आप क्या करते हैं कि you are going to hide your data behind a particular picture or a particular sort of media that is, I mean, over a computer. So the very existence of the data is concealed as illustrated in the figure. अब next में मैं आपको बताऊंगा कि किस तरह से you are going to hide your data behind any type of picture. So only the sender and receivers are supposed to be able to see the message. I mean, The message that is being hidden behind that particular picture is only being seen by the sender as well as the receiver. In between, nobody can see that particular message because it is secretly hidden using a graphic, a wave file, I mean to say that sound file, document or other type of media. So the message is not encrypted, just hidden. This is very important. आपका मैसेज इनक्रिप्टेड नहीं है, ठीक है, ये आपके पास क्या है, हिडन है. सो यू मस्ट हैव टू बी वेरी मच क्लियर बिटवीन द encryption and the steganography. Steganography is something you are hiding your data behind certain sort of, I mean to say that picture, wave file or something like that, right? So if you can see this particular diagram, this is a very simple picture in which there is a doggy and he's just lying down on certain sort of surface, right? Now in this particular picture there is some message that is being hidden, and that message is weapons are stockpiled in this hill, in the hills. ठीक है जी, ये आपके पास एक मैसेज जो है इसके अंदर हिडन है, स्टेगनोग्राफी हुआ है, ठीक है. एंड व्हेन दिस पिक्चर इज बीइंग received by the receiver, he can only reveal that particular information from this particular picture. How it is going to be done? A method of embedding the message into some type of medium is to use the least significant bit, or you may call it as LSB. Many types of files have some bits that can be modified and not affect the file they are in, which is where secret data can be hidden without altering the file in a visible manner. अब इसमें होता क्या है? Definitely you know that आपके पास 2 GB या 3 GB या 3 MB की different files होती हैं, ठीक है. What you are going to do, and every picture or every wave file is a combination of multiple bytes, और बाइट्स आर द कॉम्बिनेशन ऑफ डिफरेंट सेट ऑफ बिट्स, और हर एक बाइट के अंदर आपके पास LSB होता है और मोस्ट सिग्निफिकेंट बिट होती है, और एक आपके पास होती है लीस्ट सिग्निफिकेंट बिट. सो इन दिस पर्टिकुलर सिनेरियो व्हाट यू आर गोइंग टू डू, you are going to alter or you are going to add certain sort of information at the least significant bit of that particular byte of that particular picture or that particular media. This is how you are going to modify or you are going to hide certain information at the back end of that particular picture, right? So many types of the file have some bits that can be modified and not affect the file they are in, which is where secret data can be hidden. So without altering the file in a visible manner. I mean, most of the time, definitely when you are adding certain sort of information to the least significant bit, it might, I mean to say that affect the quality of that particular picture, and the invader can easily understand this picture has been modified or something like that. But there are certain pictures or there are certain files which might not have certain sort of effect over that particular file when you are making changes inside the least significant bit of that particular data, right? So this is how you are going to alter the picture and adding certain sort of information or hiding certain sort of information inside that particular picture, and this is what you can call it as a steganography. So in the LSB approach, or you may call it as least significant bit approach, graphic with a high resolution or an audio file that has many different types of sound like high bit rate are the most successful for hiding information within, right? So there is commonly no noticeable distortions and the file is usually not increased to size that can be detected, right? Now you can hide your data in which you, the files which have the high resolution or an audio file that might have many different types of sound like high bit rates. So these are the most successful wave files, or you may call it as a graphic for hiding certain sort of information within those particular files and graphics. So there is commonly no noticeable distortion. I mean, you might not be finding any sort of intrusion or distortion in those particular files when you are increasing the values of the most significant or least significant byte, and the file is usually not increased to a size that can be detected. और ऐसा भी आपके पास नहीं होता कि आपके पास फाइल की साइज इंक्रीज हो जाए and it would easily be detected कि इसके अंदर कोई चीज ऐड की गई है, ठीक है. So this is how your steganography is being implemented. Now see, this is an example of an steganography. On the left hand side you may see a picture of tree, right? I mean, this is a very simple picture, and on the right hand side you may see a picture of a cat. Now actually what happened, that particular picture of a cat is being coming out from this particular, I mean to say that tree, right? Actually this has been steganographed in that particular picture, and when we have changed the values, actually that picture has been resolved, or it has been converted to a picture of a cat, right? Image of a cat extracted from the image of the tree. Now how it has been happen, image of a tree removing all but the two least significant bit of each color component produces an almost completely black image, making that image 85 times brighter, produces the image of the cat. Now what happens, actually what he has done, he has taken an image of a tree and he has removed all बट द टू लीस्ट सिग्निफिकेंट बिट्स जो आपके पास होंगी हर एक बाइट की और कलर कंपोनेंट की, ठीक है, उसको उसने रिमूव की है, प्रोड्यूस एन ऑलमोस्ट कंप्लीटली ब्लैक इमेज, जिसकी वजह से आपके पास इफेक्ट क्या आया पिक्चर के ऊपर, इट बिकम्स होल ब्लैक. नाउ व्हेन इट बिकम्स ब्लैक, देन व्हाट ही हैज डन, he has make an image 85 times more brighter than the normal image. When it apply this particular technique over the same picture, then it becomes the image of a cat. This is how you are going to hide certain sort of information behind some other picture. Okay, so this type of steganography is referred to as digital right management. The goal is to restrict the usage of material that is owned by a company or individual. अच्छा जी, अब digital watermarking हमारे पास क्या होती है कि we are going to embed or trademark on behind the text, right? And one who do not want to reveal his information or who do not want to allow any other person to use his material, he used to place digital watermark onto his notes or something like that. I think you people are very well aware about these type of things. When you people are doing your intermediate or first year and you are taking notes from your particular teachers of mathematics or computer science or like that, they are going to place digital watermark over those particular text or the particular notes, so that that particular note cannot be used by some other entity. This is what the digital watermarking is, right? So these are put into place to deter people from using material that is not theirs. अब हम इसमें क्या करते हैं कि हम अगर किसी third person को इसको use नहीं करना इस material को, तो we are going to put the digital watermark. So this type of this is, make sure this is also a type of steganography, and this is being used as, or this is being called as your DRM, or this is called as your digital right management. The goal is to restrict the usage of material that is owned by a company or an individual. ठीक है, इसकी एग्जांपल मैंने जो आपको बताई थी वो ये थी कि सोनी ने अपनी रूट किट इंस्टॉल की थी आपके कंप्यूटर्स के ऊपर, so that nobody can copy the original Sony files, video files, audio files and cannot sell them to the market. तो DRM जो उन्होंने डिजिटल राइट मैनेजमेंट की जो रूट किट इस्तेमाल की थी, एक्चुअली दैट वाज vulnerable to certain sort of attacks. They have opened all the ports of their computers, और जब यूजर्स को पता चला कि उनके कंप्यूटर्स vulnerable हो गए, so they I mean due to that reason Sony has removed that particular rootkit from that particular computers of their users, right? So that was the example that I have told you regarding the digital right management in my previous lectures, right? Now this is a picture जिसमें आपके पास लिखा हुआ है Brian Kell 2006. Even I cannot read it, right? This is what the example of a I mean to say that digital watermarking. या आप अपने notes को या pictures को watermark कर देते हैं, right? Then we have the ciphers, the types of ciphers. The symmetric encryption ciphers come into two basic types. One is called as your substitution, another one is called as your transpositions. अब cipher का तो आपको पता है, encrypted text, right? I mean, when you are going to apply certain sort of algos over your plain text, it has been converted into a text that is called as your cipher text, right? Now, how encryption is being implemented, there are two ways. One is being called as your substitution, another one is being called as your transposition. अब ये होता क्या है? Substitution ciphers क्या होते हैं? The substitution ciphers replaces bits characters और block of characters with different bits, character और blocks. Substitution में हमारे पास ये होता है कि हम जो है अपनी bits को replace कर देते हैं with some other number of bits based on certain sort of logic. अब वो logic क्या होती है? That I would like to let you know that. But the thing you need to understand, in a substitution, you are just going to replace a particular character with some other character, right? This is what you are going to say that this is an encryption by using substitution. Now, how it is going to be happen in this particular diagram, if you can see, if you have a plain text, you have a key and you have a cipher text. अगर हमारे पास plain text n है और अगर हमने उसकी key generate की है, that is 4. Now what does it mean? It means that we have to replace our n with r. अगर n को हम 4 times आके लेके जाएं, n p q r, I mean fourth आपके पास वैल्यू क्या होगी r की, तो n is being replaced by r. अगर हम o के पास जाएं तो o जो है the key is 8, o p q r s t u v w, right? Now after 8 characters the 8th one is being replaced with o, then it becomes w, and so on. This is how you are going to apply the substitution cipher over a plain text. अब होगा क्या, plain text is being replaced by that particular substitution cipher and resulting text would be your encrypted text. This is how you are going to say that your substitution is going to play a role in for doing encryption inside your scenario, right? This is what the example example of a substitution, right? A substitution cipher uses a key to dictate how the substitution should be carried out. In the Caesar cipher, each letter is replaced with the letter 3 places beyond it in the alphabet. The algorithm is the alphabet and the key is the instructions shift up to 3. The substitution is used in today's symmetric algorithm, but it is extremely complex compared to this example. Actually, substitution तो हमने पढ़ लिया. I mean, what we have learned so far, it is a key to dictate how the substitution should be carried out. In a Caesar cipher that we have gone through in our previous slide, in a Caesar cipher, the letter is being replaced with the letter 3 places beyond or forward, right? This is how we are going to apply the Caesar cipher. The algorithm is the alphabet. अब इसमें आपके पास algorithm जो है, that would be your alphabet, and the key is the instruction, or you may call it as shift up to 3. I mean, what the logic that you are doing, that is what the key, and the alphabets are your algorithms, right? If we are talking about the Caesar cipher. But when we are talking about the substitution, in a substitution we are totally replacing a particular word with some other word, right? This is what the substitution is. But actually your complexity of the substitution is much more than your Caesar cipher. ठीक है? क्यों? Because we are going to I mean repeat this particular substitution, I mean to say that algorithm, I mean many times, so that your I mean plain text would be so much complex, so nobody can easily decrypt that particular information. This is why your substitution complexity is much more than your normal Caesar ciphers or like that. In a transposition ciphers, the values are scrambled or put into a different order. The key determines the position the values are moved to as illustrated in the figure. अच्छा जी, अब ट्रांसपोजिशन साइफर में हमारे पास क्या होता है, the values are scrambled or put into a different order. अब substitution में क्या हो रहा था, we are going to replace a word or a character with some other value, but in transposition cipher we are just going to scramble certain sort of value so that it must be encrypted or something like that. So the key determines the position the value are moved to as illustrated in the figure. अब आ जाएं इस figure के ऊपर. Now let's suppose we have a little rabbit message, that is a plain text. We need to divide it into two parts, little rabbit, like broken into groups 1 2 3 4 5 1 2 3 4 5. We have divided in this way. Now what we have done, we have a key that is going to replace these particular word into a jumbled format, right? I mean to say that 2 4 1 5 3. अब 2 के ऊपर आपके पास डिफरेंट वर्ड आएगा, सेकंड वाला जो है वो आई पे आ जाएगा, ठीक है? लेट्स सपोज 2, the what is the word 2 is being here, that is I is being your encrypted or cipher text. 4, fourth one is what, T, it is being replaced by T. 1, 1 is what? L, that is being replaced by L. 5, that is again some sort of I is being replaced by 5. 3, 3 is what? T, right? So this is how you are going to apply your transposition cipher. आपने एक plain text लिया, उसको jumbled up किया, and you have divided it into I mean numbers, and then you have applied a key onto that particular broken group. I mean to say the text. Based on that particular key, you are getting certain sort of cipher text that is a jumbled one. This procedure is being called as your transposition cipher. इसमें replacement नहीं हो रही. Make sure. Like a transposition cipher, you are not going to say that this is a jumbled one, and you are going to say that you are going to replace a particular word with a particular key value. This procedure is being called as your transposition cipher, right? So this is a simplistic example of a transposition cipher, and only shows one way of performing transposition. When implemented with complex mathematical function, transpositions can become quite sophisticated and difficult to break. अब देखें, ये तो हमने एक ट्रांसपोजिशन अप्लाई की. अब इस तरह से अगर हम इसको 3 या 4 रिपीटेशन करेंगे तो how much complex it would be. ठीक है जी, ये बहुत ज्यादा कॉम्प्लेक्स हो जाएगा, and it would be very difficult to decrypt or decipher. So by applying different sort of mathematical functions, and when we are going to apply multiple types of repetitions over that particular same algorithm, so it would be very difficult to break that particular transposition cipher. We have the simplest example of a yes, it's clear. Now, symmetric algorithm employed today use both long sequence of complicated substitution and transpositions over the messages. The algorithms contains the possible ways that the substitution and transposition processes can take place, represented in mathematical formulas. The key is used as the instruction for the algorithms, dictating exactly how these processes will happen and in what order. Now see, symmetric algorithms आपके पास वो algorithms होते हैं जिसमें आपके पास key जो है sender और receiver आपके पास एक ही key को use करते हैं. ठीक है, I will have to explain this particular algorithm in future, but right now you need to understand that symmetric algorithm have the same key at both the ends, at the sender's end as well as at the receiver's end, and make sure symmetric algorithms are using the complicated substitution and transposition over those particular messages. अब कैसे encryption होती है? They used the complicated functionalities of your substitution and transposition, right? Now, to understand the relationship between an algorithm and a key, let's look at the figure, right? Conceptually, an algorithm is made up of different boxes, each of which has a different set of mathematical formulas that dictates the substitution and transposition steps that will take place on the bits that enter the box. To encrypt our message, the bit values must go through these different boxes. अब actually इसको समझने के लिए we might have this particular diagram. Now see, algorithm is a set of functions. I mean to say that you can see here there are 16 functions which are being implemented in a single algorithm. हम कहते हैं कि algorithm आपके पास different set of functions होते हैं. ठीक है. Now let's suppose we have a message that is hello mom and all that thing, right? अब इसमें हमने क्या करना है? We need to encrypt our data by using that particular algorithm, right? Try to understand the concept. Now we have a key. Now, how the key is being selected? Key is being selected by using different random functions from this particular algorithm. ठीक है, अब होता क्या है कि हमने F13 को उठाया, F6 को उठाया, F11 को उठाया और F4 को उठाया. Now we have applied this particular encryption algorithm or a key over that particular message, and the resulting value would be a cipher text. Now, when this particular key is being available to the receiver, then receiver would easily decrypt this particular information by using the same function that is being applied over in order to encrypt that particular data. ठीक है जी, हम इन सेम एल्गोरिथम सब के सब एल्गोरिथम्स को यूज नहीं कर सकते. We just need to select a particular functions from that particular algorithms और उसको हम एज अ की यूज करते हुए, की स्पेस यूज करते हुए हम अपने डेटा को एनक्रिप्ट करेंगे, और एनक्रिप्ट करने के बाद दैट साइफर टेक्स्ट वुड बी सेंट ओवर अ नेटवर्क, and that particular ciphertext, as soon as being received at the receiver's end, that particular text again is going to be converted into a plain text by using the same key by which that particular text has been encrypted at the sender's end, right? So if each of our message go through each of these different boxes in the same order with the same value, the evil door will be able to easily reverse engineer this process and uncover our plain text message. To foil an evil door, we use a key, which is a set of values that indicate which box should be used in what order and with what values. अब देखें, try to understand the concept. अगर एक एल्गोरिथम है, उसके अंदर F1 से लेके F16 तक सारे फंक्शंस यूज हो जाते हैं एंड इन द सेम ऑर्डर, और उसकी बेसिस के ऊपर आपके पास इंक्रिप्शन होती है, तो इट वुड बी वेरी इजी फॉर evil door or an invader to predict दैट पर्टिकुलर पैटर्न. उसे पता है कि जी F1 से F16 की जो पैटर्न है ना, इसको यूज करते हुए आपका डेटा एनक्रिप्ट हुआ है, तो वो उसको क्या करेगा, इजीली प्रेडिक्ट करके कभी ना कभी उसको डिसाइफर कर लेगा, ठीक है. बट इफ we need to make it more secret or more secure, what we need to do, we use the key, which is a set of values that indicate which box should be used in what order and with what values. अब की को हमने कैसे एक्सट्रैक्ट करना है, we need to randomly select different sort of functions from this algorithm. For this particular text we have selected F13, F6, F11 और F4, और definitely these are the purely random values. अब इन रैंडम वैल्यूज ने क्या करना है, इनको हमने उठाया, इनके जरिए अपने टेक्स्ट को एनक्रिप्ट किया एंड देन सेंड इट बैक टू द सेंडर और रिसीवर. अब रिसीवर को हमने यही सेट ऑफ फंक्शंस जिन ऑर्डर में हमने इसको यूज किया है, वी हैव टू सेंड इट टू द रिसीवर. अब रिसीवर क्या करेगा, बेस्ड ऑन दैट पर्टिकुलर की वैल्यू इट हैज टू डिक्रिप्ट द इंफॉर्मेशन दैट हैज बीन एनक्रिप्टेड एट द सेंडर्स एंड. सो दिस इज एक्चुअली how the encryption and decryption procedure internally works, right? So hopefully that is clear to you guys. And finally, last slide is going to tell you, so if message A is encrypted with key 1, the key will make the message go through boxes 1, 6, 4 and then 5, right? When we need to encrypt message B, we will use key 2, which will make the message go through boxes 8, 3, 2 and then 9. So it is the key that adds the randomness and the secrecy to the encryption process. अब देखें, अगर आपने मैसेज ए को एनक्रिप्ट करना है तो आप की 1 यूज करेंगे, जो आपके पास 1, 6, 4 और 5 को यूज कर रही है, ठीक है. 1, 6, 4 एंड 5 को. अगर आपने किसी और मैसेज को एनक्रिप्ट करना है तो यू माइट बी सिलेक्टिंग F1, F7, F15 और F14. इनकी कॉम्बिनेशन से जो आपके पास की बनेगी, दैट इज गोइंग टू एनक्रिप्ट यूर सेकंड मैसेज एंड सो ऑन. ये तो आपके पास एक जनरल एग्जांपल है. एल्गोरिथम आपके पास कितने कॉम्प्लेक्स होते हैं, वी डोंट नो अबाउट देम, राइट? So based on that, what is the conclusion? So the conclusion is, it is the key that adds the randomness and the secrecy to the encryption process. आपके पास की होती है जो आपके पास आपके कोड के अंदर या आपके डेटा के अंदर सीक्रेसी लाती है, not the algorithm. Algorithm is always public, I have told you that, but key is going to add randomness and secrecy to the process, which is going to encrypt and decrypt your data. So that is all from my side.